So welcome to the another session of C programming. So in this session we will be solving some basic problems on C language, right? So now let us start. So the first problem is the minimum number of temporary variables required to swap the contents of two variables. Okay. So classically, how do we approach these problems? How do we swap the variables values of two variables? So let us suppose we are having a variable A and there's a variable B, and the value stored in the variable A is 5 and the value stored in the variable B is 6. So classically what we do is we take a temporary variable and we store the value of A into this temporary variable, then we take B is equal to A and then we do A is equal to temp. So in this manner we can swap the value. So in this case, what are the number of variables temporary variables required? So the number of temporary variables required are 1. But can we do this problem without using a temporary variable, right? So the answer is yes. How? So we can do is A is equal to A plus B. That means I am adding the values of A and B and storing the values in A. Therefore the value stored in A will be 11. Then we'll do B is equal to A minus B. So now this becomes B becomes 11 minus 6 is equal to 5. Therefore the value stored in B is 5. Then we will do A is equal to A minus B. Therefore now the value stored in A is 11 minus 5 as 6. So in this manner, without using a temporary variable, we swap the values of these two variables A and B. So the correct answer is D, right? So the next question is, if integer needs 2 bytes of storage, then the maximum value of an unsigned integer is. So check it, they are writing unsigned integer. So what is the difference between a signed integer and an unsigned integer? So in unsigned integer we do not have any negative sign. So every number in unsigned integer is considered as positive. And they are saying it is a 2 byte storage, right? So if it is a 2 byte storage, then what can be the maximum value? So let us see, these are the 2 bytes of this integer. Okay, and this is the first byte and this is the second byte, right? And here this is the least significant. Here I am using showing the least significant bit, that is LSB, and it is MSB, that is most significant bit, right? So what can when you say that the value of this integer is maximum? So the value of this integer is maximum when all the bits are 1. Therefore the value will be 1 1 1 1 1 1 1 1, then 1 1 1 1 and 1 1 1 1. So these are 16 ones. So what will be the value here? So the value will be 2 raised to power 16 minus 1, right? So if you do not know how to calculate the values of these binary numbers, then please check out the lecture on how to calculate the values of binary numbers, right? So the maximum value will be 2 raised to power 16 minus 1, right? So the answer will be 2 raised to power 16 minus 1. So next question is, if integer needs 2 bytes of storage, then the maximum value of an signed integer. Here they are writing a signed integer. So what is the difference between unsigned and signed integer? So in signed integer we are having a positive and a negative sign for the integer numbers, and the last bit in the signed integer, for example this is an unsigned integer. So in an unsigned integer this is the last bit. This last bit is used as 1 in case of unsigned integer, but in case of signed integer this last bit is used to denote the sign, right? So in this case, if it is a 2 byte storage, then we can only use 15 bits. How? So the maximum value will be 1 1 1 1 1 1 1 1. This will be 1 1 1 1 and 1 1 1, and this will be this last bit. So this last bit can be 0 in case of if you are saying the maximum value, because in case of negative number, we show negative number with 1 and we show positive number with 0. So 0 means positive. Therefore the maximum value it will take is 2 raised to power 15 minus 1. Therefore the correct answer is B. Okay. Okay, so now check out the next question. So in the next question, they have given a program and they are asking the output of this program. Okay, so here we are having two variables, the variable A and the variable B. So let us suppose these are the variables. This is the variable A and this is the variable B. And the value stored in variable A is 5 and the value stored in variable B is 6. And then we are printing %d comma A double equals B. And what is this A double equals B? So A double equals B is a conditional statement. So it is a conditional statement. So what is the output of this conditional statement? The outputs are true or false. So true means when the value of A and B are same, then this conditional statement is going to give me a true output. And the value of A and B are not same, then this conditional statement is going to give me the output as false. So true means 1 and the false means 0. So here the value of A is 5 and the value of B is 6. And 5 is not equal to 6. Therefore this conditional statement is going to give me output as 0. Right? So this program fragment is going to print output as 0. So option B is correct. Right? So the next question, in the next question they have said the operator used to get value at address stored in a pointer variable. Okay. So what happens is whenever there is a variable in the C program, let us suppose there is a variable A. In computers, every variable will be having an address. So let us suppose the address of this variable A is 1000. Okay. And then there's something called as pointers. There are two things. One is variable and second one is pointer. Let us suppose if we do int A, then this is a variable. Okay. And if we do int star B, now B is a pointer and B is going to store the address of a variable. Now how am I going to store the address of a variable? If I do B is equal to and A. So in this way, I can store the address of variable A into B, right? So here we are having a variable B, which is a pointer, and because of this statement, this is going to store 1000. Okay. Now, if you want to access the value stored at the location 1000 through the variable B, then I'm going to use star. So if I use printf %d comma star of B. Now because of this star, it means to say that I am going to access the value stored at the location 1000, therefore this is going to print 5. But if I do printf %u comma B, now this %u is used to print the address stored in a variable or any other address, and this address which will be printed is in hexadecimal format, right? So the question is, the operator used to get value at address stored in a pointer variable is. That means here the address stored in the pointer variable B is 1000 and the operator which is used to access the value stored at the location 1000 is star. Therefore the answer is A. Okay. So next question is the purpose of the following program fragment. So they have given some program fragment and they have given some options. Okay. So now we have to find what is this program fragment is going to do, right? So here there are two variables. One is S and another one is B. Therefore, let us suppose we are having two variables S and B, and they are doing some kind of plus and minus. So let us suppose the value stored in S is 5 and the value stored in B is 6. So in the first statement, I am doing B is equal to S plus B. Therefore, because of this statement, the value which will be stored is in B now is 5 plus 6, which is equal to 11. Then the next statement, they are doing S is equal to B minus S, right? So the value stored in S will be 11 minus 5 is 6. Therefore, the value stored in S is 6 now. In the next statement, they are doing B is equal to B minus S, right? So the value stored in B is 11. So 11 minus 6 is 5. Therefore, the value now stored in B is 5. So the value stored in the variable S is 6 and the value stored in the variable B is 5. So if you see, they are basically if you see these variable S and B, then you will find out that they are exchanging the values of the variable S and B. So the options are option A, the transfer the contents of S to B. Yes, it is transferring the content of S to B, but it is not giving us a clear picture, right? So this option may be correct. Then option B is transfer the content of B into S. Yes, it is also transferring the content of B into S. Okay. Then option D is exchange the contents of S and B. So yes, they are swapping the values, and in swapping the values, I am covering the option A and option B, both of them. In option D, negate the contents of S and B. No, it is not negating the contents of S and B. So the option C is correct because it is also covering the option A and option B, right? So now let us check out more examples. Now consider this program. In this program, there are two variables A and B, and they are printing the value, some value then. Okay. So let us suppose the value stored in the variable A is 5 and the value stored in variable B is 6. So in the next statement they are saying printf %d A not equal to B. So what is this A not equal to B? So this A not equals B means this is a conditional statement. So conditional statement is going to give me output as true, or it is going to give me output as false, right? And true means 1 and false means 0. Now the value of variable A is 5 and the value stored in the variable B is 6, right? So when I am doing A is not equal to B, that means I am comparing their values. If their values are not equal, then this is going to give me 1, that means true. If their values are equal, then this is going to give me false, that is 0. Okay. So here their values are not equal, therefore this is going to give me output as 1. This is going to return as 1, therefore I am printing the value 1. So option C is correct. Okay. So now check out the next program fragment. Here I am having some variable and using the concept of pointers. Okay. So this is a variable A and the value stored in the variable A is 5. Then in this next statement there is a pointer B which is storing the address of variable A. So let us suppose the address of variable A is 1000 and we are having a pointer B which is storing the address of A, therefore B is going to store 1000. Okay. And in the next statement we are doing star of B is equal to star of B plus 2. So that means here because of this star I am accessing the value stored in that location 1000, right? So this statement essentially means A is equal to A plus 2 because the value stored in 1000 is 5, which is the value of variable A. So it is equal to A, this is equivalent to A is equal to A plus 2. So this means it is making the value stored in the variable A is 5 plus 2 is 7. Then it is going to print the value of the variable A. So it is going to print the value 7. So the correct answer is C. Okay. So now check out the next program. So in the next program, they are giving some if-else statement and they are asking the statement S2 will be executed if. So when will the statement S2 will be executed? Okay. So here these if-else statements are does actually mean something like this. If, because they are nested if-else. So if A is greater than B, then if B is greater than C, then execute S1, otherwise execute S2, right? So the value, so when will this else statement S2 will be executed? So this statement will be executed only if this condition is true and this condition is false, then only this S2 statement will be executed. So this condition is true, therefore A should be greater than B, it should be there, and this should be false, that means B should be less than equal to C, this should be there, then only this statement S2 will be executed, right? And let us check out the options now. The first option is A is less than equal to B, which is wrong. The second option is B is greater than C, which is wrong, right? Because this is violating this condition. The third option is B is less than equal to C, yes, and A is less than equal to B, which is wrong. So this is correct, but this is wrong. Okay. Now the last option is A is greater than B and B is less than equal to C, right? So this is true. So the answer is option number D. Okay. Okay. Now check out this program. So in this program we are doing a some less than sign, which is used 2 times, is equivalent to doing some of this. So if you know this sign, then this sign is left shift. So whenever we do a this, that means I am shifting the bits in the stored in the variable a by 1. Okay, so if you see it like this, let us suppose we are having a variable a which is of 1 byte. Okay, and the value stored in the variable a is 192. So how do you represent 192? So 192 can be represented like 0 0 0 0 0 0 1 1. So this is 2 raised to power 6, and this is 2 raised to power 7. Therefore 2 raised to power 7 plus 2 raised to power 6, which is equivalent to 128 plus 64, which is equal to 192, right? So if we use this operator, this is a left shift operator. That means I'm shifting the values I'm shifting the bits. So this bit will be shifted. So if this is a 1 byte, then this bit will be lost. This bit will be shifted to its location. Then this bit will be shifted. This bit will be shifted. This and this. All these bits will be shifted. So the new bit after doing this operation is going to be 1 0 0 0 0 0 0 0. Okay, and this last one will be lost because this is only a 1 byte variable. So every bit is shifted to the left position from right to left. Okay, so that means I'm losing 1 bit. Okay, now this is also used for giving a power of 2, for multiplying any variable with the power of 2. Okay, how? Now let us suppose if we are having a variable as let us suppose a is equal to 4. So how this a is stored in bit format? So this a will be stored something like, it will be 0 0 1 0 0 0 0 0. So it is 2 raised to power 2, right? Now if I do a left shift by 1, that means this complete bit will become 0 0 0 0 1 0 0 0. That means I've shifted every bit by one location, every bit by one location, every bit by one location. The last bit is lost. So but now the value stored in this variable a becomes 2 raised to power 3, which is equivalent to 8. So now the value stored in the variable is a is 2 raised to power 3, which is equivalent to 8. That means I've multiplied the variable a with 2. So that means 4 into 2 is 8, right? So that means with the help of this operator we can also do a multiplication of 2, right? If you take any number and if you do a left shift operator, then it is equivalent to essentially doing a multiplication of 2, but I am also losing 1 bit. Okay, so if for example if this is a number that is 192, and if we do a left shift operator and this is we are expecting the output as 192 multiplied by 2, which should be equivalent to 300 something. Okay, but it is not going to give me as this output 300 something because I've lost 1 bit. So the new value of this 192 will become 128, right? So that means in every case it is not going to do a multiplication by 2, but in some cases it is going to do multiplication by 2. Okay, so first option is multiplying by 2. Yes, it is doing multiplying by 2, but in some cases, for example, the number is 192. In this case it is not doing a multiplication of 2, therefore this option is wrong. Okay, now check out the next option. So next option is division by 2. So this is also wrong. The third option is addition of 2 into 2 to a. This is also wrong. The option is none of the above, right? So the correct answer is none of the above. Okay, the next question is, the most significant bit will be lost in which of the following operations? So this is the right shift operator and this is a left shift operator. So in the right shift operator, the most significant bit will not be lost. How? Because let's suppose this is a number. Okay, now if we do a right shift, so the right shift will shift every bit to the right. Therefore by doing a right shift, this number will become 0 1 1 0 0 0 0 0. So in this case I have not lost the most significant bit, but in case of left shift operator I have lost the most significant bit, which I have shown in the previous question. So the answer is B. So in question number 13 we have some variables, and then we have to find what are the statements do. Okay, so here we are having the variable int a comma star b is equal to and a comma double star c is equal to and b. Okay, so which is equivalent to, there's a variable a, let us suppose the address of this variable a is 1000. Okay, then there's a variable b which is a pointer which is storing the address of variable a which is 1000. Now let us suppose a variable address of variable b is 2000, and there's a pointer c which is storing the address of b. So the pointer c is storing the address of b which is equivalent to 2000 sorry. So let us suppose the address of c is 3000. Okay, then we are doing a is equal to 4. So the value stored in variable a is now is 4. Then we are doing double star c is equal to 5. So this statement is star c is equal to 5. So you can view this statement as star of star c is equivalent to 5. So what is this star c? That means I am accessing the value stored at the location 2000, right? So the value stored at the location 2000 is 1000, and then I'm going to do the star of 1000, and the star of 1000 is the value stored at the location a. That means I'm accessing the variable a, right? So this is accessing the variable b, and this is accessing the variable a, and then in that location 1000 I'm storing the value 5. So now it is going to update the value at variable a as 5. Okay, now that means if now the value of value stored in the variable a is 5. The option 1 is does not change the value of a. Yes, but it changed the value of a. The value of a is 4, so it changed the value of 4 to 5. Then B is assign the address of C to A, right? So no, it does not assign the address of this statement is not assigning the address of C to A. Then assigns the value of B to A. So the value of B is 1000, so no, this statement is not assigning the value of B to A. And the option D is assign 5 to A. Yes, these statements assign the value 5 to variable A, therefore the option number D is correct. Okay, so in this next question they have given a two variables a and b which are of float type. So the value stored in the variable a is 0.5 and the value stored in the variable b is 0.7. Okay, and then in the first if condition they are saying if b is less than or equal to 7, right, and the value stored in b is 0.7 which is equal to less than or equal to which is less than 7, therefore this condition is true. So I'm going to execute this statement. So the next statement is if a is less than or equal to 0.5 and the value stored in the variable a is 0.5, therefore this condition is false. So this is not going to execute this statement. So it is going to execute this else statement. So it is going to execute this one, and this if else statement, this else statement is related to this if, and this else statement is related to this if. So we can write this same program something like this: if b is less than or equal to 7, okay, then if a is less than 0.5, then printf IES else printf PSU or else printf gate. Okay, right? So this condition is true, this condition is true, this condition is false, therefore it is going to execute this statement. So the output which this program is going to print is this option A. Okay, so now check out the next question. So in this question we are having a printf statement, printf %f comma 9 by 5. So this is 9 by 5 and 9 and 5 both are integer numbers. So but we are printing this integer number in %f, but as this is an integer number, so 9 by 5 is 1.8 but as this is an integer numbers, therefore it is going to neglect this value, so it is going to print 1.00, so the output will be B. Okay, so in the question number C, I am doing a type conversion. That means I am changing the type from integer to float in this case. So it is going to print 9 by 5 as 1.8. So it is going to take this 1.8 in a floating point value. Therefore it is going to print 1.8. Okay. Then the next question. So they are doing if A equals 0, right? So the question statement is if A equals 0, that means the value of 0 is going to be stored in the variable A, and this variable A is going to return this value which is 0. Therefore this statement essentially means if 0, right? If 0 means false, right? Therefore this is not going to execute this statement, so it is going to execute this statement. So output will be A is not 0. The option B is correct.